Hi, this lesson is about solving radical equations. So when you have a radical equation, you will have an equation with at least one radical in it. And it could be of any root. It could be a square root, a cube root, fourth root, etc. The goal is to get the radical on one side of the equation and the rest on the other side of the equation and simplify as much as possible. And then to be able to eliminate that radical by raising both sides to the power that corresponds to the radical. So in other words, if you have a square root, you'll be squaring both sides. If you have a cube root, you'll be cubing both sides. Okay, so here's our first example. We want to solve 2 root x minus 6 equal to 10. So as I mentioned, you want to get root x alone. So we do that by adding 6 to both sides. So that gives us this line right here. 2 root x equals 16. Then, in order to get root x alone, we divide both sides by 2. That allows us to cancel the 2's on the left. And on the right, you get 8. So root x equals 8. Then we want to square both sides. And we square both sides to get rid of the radical. The square root of x squared gives us x. And 8 squared gives us 64. With radicals, it's important that you check your solution. Even if you did everything correct, sometimes the solution does not work in the original equation. So it's a good habit for you to get into by just plugging in and seeing if the left side equals the right side when you plug in the answer. So here, the work is 2 root 64 minus 6. We want to know, does that equal 10? So root 64 is 8. So I get 2 times 8 minus 6. So that's 16 minus 6. The left side equals 10, just like the right side. So 64 checks out, and that's your solution. Okay, so now here's another example in blue. We have the square root of y plus 1 equals negative 2. So again, you want to square both sides. My radical is already alone, so square both sides. I get the square root of y plus 1 raised to the second power equal to negative 2 raised to the second power. Well, the square root of y plus 1 squared is just y plus 1. Negative 2 squared is 4. Then subtract 1 from both sides, we get that y is equal to 3. So I actually put a slash through it because it doesn't work, and the work is here on the right. If you plug in 3 into the original equation, you need to check if the square root of 3 plus 1 equals negative 2. Well, the square root of 3 plus 1 is a square root of 4. Square root of 4 is 2. You want to make sure you always give the principal square root. And 2 is not the same as negative 2. Therefore, this is an example of a radical equation with no solution. Okay, so here's another example. Here in green, I have 0 equals the square root of 3x minus 5 minus 7. So again, here I have a radical with 2 terms on the inside, but that minus 7 is on the same side as the radical. So the first thing you want to do is add 7 and move it over to the left side. So that's our first step. Then we square both sides. So I get 7 squared equals to the square root of 3x minus 5 squared, which leaves us with 49 equals 3x minus 5. Then you just have a linear equation. You want to add 5 to both sides, so you get 54 equals 3x. Divide both sides by 3 to get x alone, and you get that x is 18. If you were to check it, it works, so you have a good solution. All right, so here's another example. This one's a little bit different in that I have a cube root this time. So I want to solve the cube root of 4y plus 2 equal to 0. So again, let's isolate the radical by subtracting 2. So I have the cube root of 4y equals negative 2. And then instead of squaring both sides as I did in the previous examples, this time I need to raise both sides to the third power, but that's because I have a cube root, right? Always raise it to the power that corresponds to the root. So the cube root of 4y raised to the third, well, that's just 4y. That's what that technique allows us to do, is to get rid of the radical, and you're only left with the expression on the inside called the radicand. And on the right side, negative 2 to the third power is negative 8. Then divide both sides by 4 to get y alone, and you get that y is negative 2. The check is here on the right. It works, so you can say that y equal to negative 2 is a solution to the equation. All right, this next example is a little bit more complex because I have two radicals on two different sides of the equation. I need to solve the square root of x plus 7 equal to the square root of x plus 1. So I'm going to take the same approach. I really can't isolate a radical on one side because I have more than one. So I'm going to go straight to squaring both sides because I have a square root. On the left side, that will simplify immediately. Square root of x plus 7 just becomes x plus 7. But on the right side, I actually have to expand this binomial, which means I have to FOIL it. I have square root of x plus 1 times square root of x plus 1. So on the third line, this is what I did, the FOILing. So my first term, root x times itself, is x. Outer and inner, that's root x and root x, so that's 2 root x. And then last is 1. So I get the three terms on the third line of this problem. All right, so now I need to do the same process. I need to isolate this term. You need to get the radical alone, which means you're going to subtract x and subtract 1 from the right side to move it over to the left side. When you subtract x, the x's will cancel. When you subtract 1, you get the 6 that you see here on the left. So I have 6 equals 2 root x. Now remember, you still need to isolate the radical. So I'm going to divide both sides by 2. When you divide both sides by 2, you get that 3 equals root x. And then repeat the process of squaring both sides. So I have root x squared equals 3 squared, so you get x is equal to 9. The check is here on the right. It works, so you get one solution, which is 9. Okay, let's move on to the next problem, which also has two radicals. I want to solve the square root of x plus 10 plus the square root of x minus 15 equal to 5. So unlike the previous example, in this case, my two radicals are on the same side of the equation. So you still want to isolate one of them so that we can simplify at least one radical right away. What that means is I need to either subtract the first one or the second one to move it over to the right. I chose the second radical. So I'm going to subtract square root of x minus 15 from both sides. That leaves us with this equation. All right, so now we need to square both sides, which is what you see here. When you square the left side, it immediately simplifies to just x plus 10. So part of the equation has already been simplified. But on the right side, you have to FOIL it, which is what you see here. I need to expand 5 minus root x minus 15 times itself. So when I do 5 times 5, the first term, so that's first right here, you'll get 25. When I do my outer, that's negative 5 root x minus 15, and my inner is also negative 5 root x minus 15. That's where we get this, negative 10 root x minus 15. And then my last, multiplying these two radicals, a negative and a negative means I get a plus here, and the radical cancels out because they're the same. So you just get x minus 15. All right, so now I'm left with the work right here on this line. I have some like terms, the 25 and the 15, so I'm just going to rearrange things a little bit. So I'm going to write the x first. 25 minus 15 is 10, which is what you see on this line here. And then I have my radical minus 10 root x minus 15. Okay, so similar to what I described in previous examples, now you need to isolate the radical of minus 10 root x minus 15. And the way we're going to do that is that we have to subtract x and subtract 10 and move it over to the left. When I do that, your left side just becomes 0. So I have 0 equals negative 10 root x minus 15. Then divide both sides by negative 10. They cancel. So you get 0 equals root x minus 15. Square both sides again in order to get the x out of the radical. So you get 0 equals x minus 15. Add 15 to both sides, you get a solution of 15, which works if you go back and substitute. The left side will equal the right side, so you get one solution. Okay, so the second part of this lesson are word problems where you will be using radicals in order to solve an equation. But first we need to remind ourselves of a very important theorem in mathematics called the Pythagorean Theorem. This theorem is based off of a right triangle. A right triangle means that it is a triangle, a three-sided shape with a 90-degree angle in it. And we usually put that little box in the corner where the 90 degrees exists. The two sides of the triangle that meet in this corner here to create the 90 degrees are called the legs. The side opposite of the 90 degrees is called the hypotenuse, spelled like this. And the other two were legs. So when you have a right triangle, the Pythagorean theorem says what you see here in the box. It says that a leg squared plus the other leg squared equals the hypotenuse squared. I'm calling my two legs A and B. I'm calling my hypotenuse C. Okay, so let's use that theorem in order to solve a few problems. So it says if a triangle has legs with lengths 5 and 12, find the hypotenuse. So I drew a picture here. Doesn't really matter where you put the 5 and the 12 as long as they meet in this 90-degree angle. So in other words, you could have written the 5 here and the 12 here. It won't make a difference in terms of your computation. We need to solve for the hypotenuse, so I'm just going to call it C. You could really call it anything you want. So here's my theorem. 5 squared plus 12 squared equals C squared. In the next line, square the 5 and the 12, so you get 25 plus 144 equals C squared. Add the 25 and the 144, that's 169 equals C squared. Then we need to solve for C, and we do that by taking the square root of both sides of the equation, which is what you see here. So C is equal to 13. Now, normally we would say plus or minus 13, but because we're solving for the side of a triangle, you can't have a dimension that's negative. Would it make sense? You ignore the negative and just choose the positive result. So C is just 13. All right, so here's another example where you will be using the Pythagorean theorem. It says a plane leaves an airport traveling south at 300 miles per hour, and a second plane travels east from the same airport at 400 miles per hour. How far apart are the planes after 2 hours? All right, so here's our airport. And so here we see the plane is going south, the first plane. It's traveling at 300 miles an hour for 2 hours. That means it traveled 600 miles. Then we have another plane traveling east from the same airport, so it's going in this direction. That plane is traveling at 400 miles an hour for 2 hours, so that means it traveled 800 miles. So the two legs of the triangle that you see in the shape are 600 miles and 800 miles. And we need to find how far apart the two planes are, which again turns out to be the hypotenuse of this right triangle. So applying the Pythagorean theorem, I need to solve for C. I have C squared equals 600 squared plus 800 squared. Square the 600 and the 800. So you get C squared equals 360,000 plus 640,000. Add those two numbers and you get that C squared equals a million. When you take the square root of a million, that's a perfect square. It means that the two planes are 1,000 miles apart. All right, let's do one more. This one will require a calculator. So it says if a television is 27 inches high and has a 33-inch diagonal, find how wide the television is rounded to the hundredths place. So here's my television. So it has the shape of a rectangle. It's 27 inches high, which means it's 27. The diagonal is the line that goes from one corner to the opposite corner. So that's this line right here. That's 33 inches. And we want to know how wide the the television is. So I'm just going to call that unknown X. You could call it anything you want. So by drawing that diagonal through the rectangle, you've actually created a right triangle. So that's indicated here with this little box. So that means, again, I can use the Pythagorean theorem. X is a leg of the triangle. 27 is the other leg. 33 is the hypotenuse. So here's our Pythagorean theorem equation. I have x squared plus 27 squared equals 33 squared. Remember, you need to solve for x. So I'm going to subtract 27 squared from both sides. All right, so in the next line, I'm going to square the 33 and the 27. That's what you see here, 1,089 minus 729. Subtract those two numbers, and you get that x squared equals 360. Now we take the square root of both sides so that we get x alone. That's what you want. And then you want to take the square root of 360. Now, although 36 is a perfect square, 360 is not. So at this point, you should plug that into a calculator, take the square root of 360, rounding to the hundreds place as indicated in the directions means that you want to round to the second decimal place, which means you look at what's to the right of the second position. In this case, the number to the right of 7 is something less than 5. So your width is approximately 18.97 inches. Okay, that's it for this lesson. You should try doing the homework.